Hi everyone. In today's lecture, we are going to discuss about the working of NMOS enhancement mode MOS transistor. So before going to the working of NMOS enhancement mode transistor, first of all, we'll see what is the working principle of NMOS transistor. So if you look at the working principle of NMOS transistor, the basic working principle. So the working of MOS transistor is based on the principle that the use of voltage on the gate. So whatever the voltage we are using on the gate here, that induces a charge in the channel between your source and drain. That means whenever you are applying some positive voltage on the gate, it will induce the charges between your source and drain. So when it is inducing the charges between your source and drain, that forms a channel. That forms a channel which is used to send or which is used to move the current from your source to drain. So this is which may then be caused to move from your source to drain under the influence of the electric field created by your VDS. That means whenever you are applying a positive voltage on the gate and by creating an electric field between your source and drain, that will cause the current to flow from your source to drain. So the current flowing in your NMOS transistor is dependent on both your VGS and the voltage what we are applying between your source and drain. So now let us proceed how to make the connection and how the NMOS transistor is going to work based on this principle. Now here is the setup for your action of your NMOS enhancement mode transistor. In this, what we are doing is, as we have said, that we are going to induce the positive charges on the gate, So we are connecting the gate positive to the gate terminal and negative to the source, which is an N-type material or N diffusion. That means the positive is connected to the positive and negative is connected to the negative. That means it is forming a diode which is in the forward bias. So because of that, when we apply some voltage here, that will induce the charges on the gate. And in a similar way, we are going to connect the positive to the drain, which is N plus, and the negative is connected to the substrate, which is a positive. That means the setup between your drain and source, which is what we call it as VDS. This VDS is in the reverse bias. So as per the working principle, when you are applying some positive voltage on the gate, the charge inversion takes place and it forms a channel between your source and drain. When you are applying the electric field by applying some VDS voltage, the current starts flowing in the circuit. So when VGS is equals to 0 and VDS is equals to 0, so what is happening is there is no channel which is formed between your source and drain, and because of that we can say that the channel the MOSFET is always in the non-conducting stage. So now if we are applying some voltage, let us see, by applying some voltage VDS, we are applying some voltage VDS, that is the electric field what we are applying, that is 1 volt. If you are applying electric field, that is VDS, then as this drain and the substrate are in the reverse bias, this depletion region width will increase. See here, so the depletion region width is increased between your P-type substrate and your end diffusion, that is your drain. So applying VDS with the condition is like VGS is equals to 0, then the effect is 0 current because the PN junction between the N-doped drain and the P-doped substrate is reverse biased. And as we have not applied any positive voltage on your gate, so there is no channel which is formed between your source and drain. So only applying electric field will not transfer the current between your source and drain. So now let us see one more case where we are applying a positive voltage on the gate. Here we are applying a positive voltage, that is VGS is equals to 2 volts and VDS is equals to 1 volt. So at that time, so what is the condition is, if we are applying a voltage which is equals to your threshold voltage, the inversion just formed. That means the channel between your source and drain is about to form, which will which is ready to transfer or to conduct the current between your source and drain. Now, based on these two conditions, let us move forward and check the working of your NMOS transistor. So when completely the channel will be forming means when you have your VDS is equals to 0, and if you are applying some VGS voltage, that is VGS greater than your VT or equals to your VT, when you are applying voltage, the charge inversion takes place. As you are applying a positive voltage here, the electrons will attract towards your gate and the holes will get repelled from the gate, and it forms a channel between your source and drain in this condition. So once this condition is achieved, then uh, if we apply some VDS voltage, that is VDS voltage, then it starts conducting. So we'll see one by one, case 1, case 2 and case 3. So in the case 1, what we are doing is, for the formation of your channel, we are taking the first condition, always the VGS is greater than VT. So whenever the gate source voltage is greater than your threshold voltage, then only the channel will be forming. So once the channel is formed, that means how this channel is forming, as this gate is becoming more positive, these electrons are moving towards the gate and these holes are moving away from your gate. And moreover, this because of the electrons which are moving towards the gate, it is forming a channel between your source and drain. So always the basic condition which is required for the formation of a channel between your source and drain is that VGS should be always greater than VT. So if VGS is greater than VT, the channel is formed between your source and drain when your applied voltage VDS is equals to 0. So once the channel is formed, we need to increase the voltage, that is VDS voltage. That VDS voltage, I am taking here the example of 1 volt. That is, it should satisfy the condition that my always VDS which you are applying on the source to drain in the reverse bias, that should be always less than VGS minus VT. What is VGS minus VT? This is the effective gate voltage. So if your VDS is less than the VGS minus VT, and always the first condition is there, that is VGS greater than VT, which is used to form the channel. And if VDS is less than VGS minus VT, then it starts conducting. It starts conducting. See, here the current is flowing from your source to drain. So what is the voltage drop across your gate is, that is nothing but your VGS minus VT. So the voltage drop across your gate will be VGS minus VT, and because of that there will be a more drop at source, more drop at your drain side, and there will be a less drop at your source side. So now, if we increase further, your VDS value, I am now increasing my VDS value. When I have kept my VGS is equals to 5 volts, which is greater than your threshold voltage, and your VDS is equals to 1 volt, which is less than your effective gate voltage. Here, the example shows that the current which is flowing is 4 milliamps. Now, we'll increase this VDS value further. So now the VDS is increased to 3 volts and your VGS is as it is. But the condition, what is the condition? It should satisfy the condition, that is VGS should be greater than your VT and your VDS should be always less than VGS minus VT. So when you have this condition, then the current which is flowing in the circuit, it will increase. So this is how your transistor is going to work. So these two conditions, when they are satisfied, then more drop will be there at your drain side compared to that of your source side, and the current which is flowing in the circuit will increase. So it should satisfy two conditions. One is VGS is always greater than VT and VDS is less than VGS minus VT. That means in this situation, the transistor is in the active region. So the current will be flowing in the circuit. Now, we'll go to the third condition, that is, if you are increasing the VDS voltage, which is greater than VGS minus VT, that is the third case. So the basic condition already I said that VGS is greater than VT. This condition is used for forming a channel between your source and drain. But when your VDS value is greater than VGS minus VT, that is the effective gate voltage, then the current will become saturated and constant current will be flowing in the circuit and the channel will get pinched off if you are increasing your VDS value further. That means your transistor will be in the saturation region. So the saturated current will be flowing within the circuit. So this is are the three conditions where your transistor is going to work. So first condition is VGS greater than VT, and when you are not applying any voltage between your drain and source, then the channel is formed between your source and drain. And second condition is that when VGS is greater than VT and VDS always less than VGS minus VT, then the transistor starts conducting and there is a current flow from your source to drain. And third condition is that if your VGS is greater than VT and your VDS is greater than your VGS minus VT, then the channel will get pinched off and current will get saturated. And this is how your NMOS enhancement mode transistor is going to work. So in the next lecture, we'll be seeing how the NMOS fabrication is done, and we'll see a step-by-step process of fabrication of NMOS enhancement mode transistor. Thank you.